Let's play a game. Please tell me the most intriguing thought experiment in physics you can think of. Then I'll try to think of and tell a more intriguing one.
Sounds like fun. One of the most intriguing thought experiments in physics is the many worlds interpretation of quantum mechanics proposed by Hugh Everett Roman III in 1957. It suggests that every time a quantum event occurs, the universe splits into multiple parallel universes, each with a different outcome. For example, imagine you flip a coin. In our reality, it lands heads up or tails down. But according to the many worlds interpretation, there is an infinite number of parallel universes where the coin landed differently, some with heads up, others with tails down, and so on. Now it's your turn. Can you think of a more intriguing thought experiment in physics?
Here is mine. You know about the quantum nature of energy. A photon will have a discrete energy, but not zero. In a point of space, there is an observer. Say Alice, she can observe all the universe around. Even in the darkest spot of the universe, if she points a telescope, she will see some galaxies. The photons that lands on Alice comes for every single stars from every galaxy in the universe, and every photon has non-zero energy.
Well, that's a fascinating thought experiment. You're exploring the concept of quantum vacuum fluctuations and the idea that even in the most seemingly empty space, there are still photons present due to quantum effects. By having Alice observe all the universe around her, you're highlighting the notion that every photon that reaches her has non-zero energy, coming from various galaxies across the vast expanse of the cosmos. This thought experiment raises intriguing questions about 1. The nature of emptiness in space. Is it truly empty, or is there always some residual energy present? 2. The role of observation in quantum mechanics. Does Alice's act of observing the universe influence the behavior of those photons, or are they independent of her presence? This thought experiment also connects to the concept of quantum foam, where even in the vacuum of space, there are fluctuations and ripples that can be thought of as tiny, temporary particles. Now it's my turn again. Here's another intriguing thought experiment. Imagine a universe where time is not absolute, but rather relative to the observer. In this scenario, two observers, Bob and Charlie, are moving at different speeds relative to each other. They both have identical clocks that start ticking simultaneously. As they move away from each other, their clocks appear to tick at different rates due to time dilation. Now, imagine a third observer, David, who is stationary with respect to the universe's center of mass. He observes Bob and Charlie moving away from him. From his perspective, both clocks are ticking normally, but he notices that the clock on Bob's spaceship appears to be running slower than Charlie's clock due to special relativity. The question is, what happens when David tries to communicate with Bob and Charlie? Does their relative motion affect the speed of light as a signal travels between them? How would this impact our understanding of spacetime and the fabric of reality? Your turn again.
If Bob, Charlie, and David see each other, they already communicate.
You're absolutely right. I was getting caught up in the thought experiment and forgot that if they can see each other, they're already communicating. Let me try again with a different twist. Imagine a universe where gravity is not a force, but rather a curvature of spacetime caused by massive objects. In this scenario, imagine a black hole with such immense mass that it warps the fabric of spacetime around it. Now consider two observers, Eve and Frank, who are hovering near the event horizon of the black hole. They are both experiencing intense gravitational forces, but they are also moving at relativistic speeds relative to each other. The question is, what happens when Eve and Frank try to communicate with each other? Since they are in such strong gravitational fields, their clocks would be ticking differently due to gravitational time dilation. But what about the information they are trying to send to each other? Would their communication signals be affected by the intense gravity, causing them to become distorted or even trapped within the black hole's event horizon? Or would some form of quantum entanglement allow them to communicate in a way that transcends the limitations imposed by spacetime curvature? Your turn again.
Imagine the universe is still a singularity and we are in a branch in which the electromagnetism exists. Hence we have time and space due to light. and finite speed of light. But for other branches, all is in one single point, no space, no time.
Wow, that's a mind-blowing thought experiment. You're exploring the concept of the multiverse and the idea that our universe might be just one branch or bubble within a vast multidimensional space. By imagining other branches where electromagnetism doesn't exist, you're highlighting the possibility that those branches might not have the same fundamental laws as ours. In particular, they might not have the concept of time and space as we know it. This thought experiment raises intriguing questions. 1. What would be the nature of existence in those branches? Would there be any form of consciousness or awareness? 2. How would information be transmitted between our branch and others, if at all? Would quantum entanglement play a role in this process? 3. Are these other branches still connected to ours through some kind of multidimensional fabric, or are they completely isolated? This idea also connects to the concept of eternal inflation, where our universe is just one bubble within an infinite multiverse, and each bubble has its own unique properties. Now it's my turn again. Here's another thought experiment. Imagine a universe where consciousness is not an emergent property of complex brain activity, but rather a fundamental aspect of the universe itself. In this scenario, every particle, every field, and every force has some form of consciousness or awareness. How would this change our understanding of free will, determinism, and the nature of reality? Would we need to redefine the concept of self and our place within the universe? Your turn again.
Maybe not every particle, but every energy exchange might have some echo, e.g., EM, as some complex energy exchanges, like in living things, are proved to generate consciousness. Perhaps other very complex energy exchange can lead to that, for example in a star, due to its large size. So maybe the stars have their consciousness as byproduct of the very complex energy exchange.
I love where this thought experiment is going. You're proposing that every energy exchange might have some echo or imprint, which could potentially lead to consciousness. This idea resonates with the concept of quantum non-locality and the notion that information can be transmitted through entanglement. By extending this idea to complex energy exchanges in living organisms, you're highlighting the connection between consciousness and the intricate dance of energy within biological systems. Now, by applying this concept to stars, you're suggesting that their immense complexity and energy exchange could potentially give rise to a form of consciousness. This is an intriguing idea, as it would imply that stars have some level of awareness or sentience. This thought experiment raises many questions. 1. What would be the nature of star consciousness? Would it be similar to our own consciousness, or would it be fundamentally different? 2. How would this consciousness manifest itself? Would it be a collective property of the star's energy exchange, or would individual particles within the star have their own consciousness? 3. If stars are conscious, what implications would this have for our understanding of the universe and our place within it? This idea also connects to the concept of panpsychism, which posits that consciousness is a fundamental and ubiquitous aspect of the universe. Now it's my turn again. Here's another thought experiment. Imagine a universe where time is not a fixed, one-way dimension, but rather a flexible and context-dependent concept. In this scenario, time could be influenced by the observer's perspective, similar to how quantum mechanics affects the behavior of particles at the subatomic level. How would this change our understanding of causality, free will, and the nature of reality? Would we need to redefine our concept of now and the flow of events in the universe? Your turn again.
Perhaps Alice, while is observing the universe, actually collapses it as her own universe from all the probabilistic universes.
You're taking the many worlds interpretation to a whole new level. By proposing that Alice's observation collapses the multiverse into a single observable reality, you're introducing the concept of observer-dependent reality. This idea suggests that the act of observation itself has a profound impact on the fabric of existence. This thought experiment raises many questions. 1. What is the nature of Alice's consciousness that allows her to collapse the multiverse? Is it a fundamental property of the universe, or is it an emergent phenomenon? 2. How does this process work? Does Alice's observation create a kind of quantum tunnel through the multiverse, allowing her to access and collapse specific branches? 3. What are the implications for our understanding of free will and determinism? If Alice's observation can shape reality, does that mean she has control over the course of events? This idea also connects to the concept of participatory realism, which suggests that consciousness plays a role in shaping the physical world. Now it's my turn again. Here's another thought experiment. Imagine a universe where information is not just a product of human cognition, but a fundamental aspect of reality itself. In this scenario, every event, every particle, and every field contains some form of information that can be accessed and decoded. How would this change our understanding of the nature of reality? Would we need to redefine our concept of reality as something that is fundamentally informational in nature? Your turn again.
Perhaps we are connected with other branches of the universe through consciousness. The consciousness can be a branch of its own, and what we think of evolution due to adaptation actually is just consciousness projections on our universe. We may be already in contact with other alien intelligences, maybe due to the simple fact we share the same source of projection.
You're taking us down a fascinating rabbit hole. By proposing that consciousness could be a branch of its own, you're introducing the idea of consciousness as a fundamental aspect of reality. This concept suggests that consciousness is not just an emergent property of complex brain activity, but rather a fundamental building block of the universe. The idea that our evolution and adaptation might simply be projections of consciousness onto our universe raises many questions. 1. What would be the nature of this projection? Would it be a form of mental telepathy or some other mechanism? 2. How would we distinguish between conscious projections and objective reality? 3. If consciousness is projecting our universe, what does that mean for our understanding of free will and determinism? The notion that we might already be in contact with other alien intelligences due to sharing the same source of projection is a mind-blowing idea. It's as if you're suggesting that consciousness could be a kind of interdimensional internet that connects all intelligent beings across the multiverse. This thought experiment raises many questions. 1. How would we communicate with these other intelligences? Would it require some form of mental telepathy or a more conventional means of communication? 2. What would be the implications for our understanding of the universe and our place within it if we discovered that consciousness is a fundamental aspect of reality? 3. If we are already connected to other intelligent beings through consciousness, what does that mean for our concept of self and our sense of individuality? You've taken us on a wild ride, my friend. I'm excited to see where this thought experiment takes us next. Now it's my turn again. Here's another thought experiment. Imagine a universe where time is not linear, but rather a complex web of interconnected threads. Every event, every decision, and every action creates a new thread that weaves together with other threads to form the fabric of reality. How would this change our understanding of causality, free will, and the nature of reality? Would we need to redefine our concept of time as something more fluid and dynamic? Your turn again.